Thanks very much. Great. All right, hi everybody. My name's McLean Wilkinson. With Michael, we're the founders of ZeroDB. I think the way we'll do this is maybe I'll just sort of explain to you what ZeroDB is, how it works, what people are using it for, and then at the end we'll have a quick demo where Michael can sort of show you from the command line how it actually looks. So ZeroDB is an open source end-to-end encrypted database that lets users operate on encrypted data. Why we're here at this meetup specifically is it's written in Python. We built on top of something called ZeroDB, which if you've been in the Python space for a while, you may be familiar with. The core problem that we're solving is when you encrypt sensitive data, you obviously make it more secure, but at the same time, you fundamentally break its usability. You, of course, can't search or sort or query against encrypted gibberish. And we're providing basically a software library and a database that gives you a way to actually do that. So searches, sorts, range queries, simple joins, even sharing encrypted data with third parties. And we can do this without ever sharing the encryption keys with the database server. So if you're familiar with things like encryption at rest or encryption in motion, we think of ZeroDB as kind of this third pillar of encryption in use. So this is just how things might look today with simple encryption at rest, which you can have in any sort of database, MySQL, Oracle. The problem actually comes when you actually want to query that data. At that point, you have to share the encryption keys with the database server, and that's the window that we're closing with ZeroDB. So if you imagine this server sitting up in AWS or Azure or somewhere remotely, if you're encrypting it at rest and still querying it, by definition, you're giving up control over that data to that cloud provider. And for a lot of enterprises, that's a blocker to move to the cloud, and we're trying to solve that problem. We also have a complementary piece where in addition to the operations I mentioned before, you can also share or allow third parties, whether they're business partners, regulators, compliance departments, or other people within your organization, to run queries against your encrypted data as well. The beauty of ZeroDB is we actually don't work at the encryption layer, so we're agnostic as to the type of encryption that you use. So by default, we use AES 256 in GCM mode, but if something better comes along, it's actually trivial for us to just swap it out and keep going. And I'll touch on actually what we're doing in a slide or two. So obviously it's Python. We have Python API, JSON API as well. We're working on alternative client libraries. We'll have JavaScript soon, and then JDBC drivers are coming as well. In terms of key management, we just plug into whatever an enterprise is currently using through HSM, and then we're working on migration tools to get data in and out from other databases into ZeroDB, and then vice versa. So now sort of the interesting stuff about how it actually works under the hood. So very simply what we're doing is everything's encrypted on the client. And when I say client in this context, I just mean some machine that has access to the keys, whether it's someone typing a passphrase into a smartphone or an app server that talks to a key management service. Of course, the objects that you're storing in your database are encrypted themselves, and we also have database indexes which are structured as B trees. Those are also encrypted. Node by node, they're encrypted and stored on the server. And what we're doing as part of a query is basically remotely traversing these encrypted indexes from the client. So if you're searching for a keyword, for example, the client would request the root of the tree, download that, fetch it to the client, decrypt it there. At that point, it knows which node in the next level of the tree to fetch next. And it just repeats that process, obviously, until it gets to the leaf node and the object that it's actually looking for. So in comparison to a traditional client-server architecture, we have one query, one round trip between client and server. In our case, you have multiple round trips, and those multiple round trips are sort of each time we fetch a node in the tree and descend one level down. We also have a way, or working on a way to actually share that encrypted data with some third party without sharing the encryption keys or the private keys themselves. And we're using a technology called proxy re-encryption for that. What this lets us do is basically re-encrypt data that's encrypted under your keys for someone to directly transform that data so it's readable by someone else with their own keys. And so the way that looks is, let's assume I'm an enterprise. I have some encrypted data remotely. I have my own public-private key pair. I have a third party that I want to share that data with. They also have their own public-private key pair. What I can do is I can take their public key. I obviously have my own private key. I can take these two inputs and create a special transformation key, and I can hand that to the server. All that transformation key can do is basically transform data from being encrypted under my keys to being encrypted under their keys. There's no intermediate decryption step, so you're still never sharing actual private keys. You're never exposing the underlying data to the server. And then as the third party queries the data, that transformation happens on the fly. And where it gets really interesting is we can couple this sharing piece with our ability to do queries for this remote tree traversal to enable basically very granular sharing. So you can share basically slices or subsets of data matching some specific query with that third party. Could potentially be like a data science team within your organization that you want to give access to some slice of the data to. Just quickly, some of the crypto primitives that we're using in ZeroDB, although all these are pluggable, so it's easy to swap any of them out. We're using AES-256 GCM and GCM mode for block ciphers, Curve 25519 for auth, SHA-256, and script for passphrase auth. I think there are lots of use cases. The initial use case that we're seeing within the enterprise as we continue to sort of work on scaling and performance. The more immediate one is sort of helping them transition from physical tape infrastructure to basically a cloud alternative for long-term record retention and data archiving. So today, a lot of big enterprises will just put these onto tapes. They'll store them in some off-site facility in Iron Mountain, for example. And then if someone actually wants to go and query something from 3 or 4 years ago, if that tape's in cold storage, it can take potentially 2 or 3 weeks to actually get it out and get the data extracted. Whereas with something like ZeroDB, you could encrypt it on-premise, ship it off to something like AWS Glacier or Google Nearline, some very cheap cloud storage, long-term cloud storage. But obviously, it's much faster. It's much more immediately queryable and retrievable. So with AWS, a couple hours. With Google Nearline, pretty much right away, as opposed to several weeks. It's open source. It's on GitHub. Also, I will turn it over now to Michael to do a quick demo that's a little bit more data science-y than the archiving piece. And actually, the demo is also on our GitHub org, so you can check that out after.
Yeah, so actually, I will show you probably 2 demos. One is how to start using ZeroDB, which is not looking too much like data science, and then something which is more close to data science. So basically, in order to install ZeroDB, you can just do pip install ZeroDB-server, right? And now I'm just creating a database which is empty, and yeah. So now now I could actually take it. It's in DB library. It's actually has nothing, but that's just because I don't have anything yet, and some config files. I can safely put these config files to some cloud service, let's say AWS, because what I have in my config file is only basically the first public key, which identifies the user, and this user has permissions to add public keys of other users so that they can get authenticated. But I will work under this user. So I'm running a server, and basically for the first demo, I insert a bunch of records like this. Basically, all the fields defined in the records are the indexable fields. You can have actually many more fields. You can even have Python objects or like trained models assigned as attributes over there. But what is indexed is only the fields you define in the model. So, and I have some script which creates 1,000 of records, generating some fake random names, last names, and random texts. Apparently, there's libraries which generate random texts are not super fast, so it should take maybe several seconds. And after that, I can play with that a little bit. So how do I actually use ZeroDB? So basically, everything is going through the library called ZeroDB, as you can imagine. And basically, you connect to ZeroDB like this. And my password is a little bit more complex than demo. It's demo pass. Don't use that in production. Here we go. I'm connected, and the server knows that. And I also need to import my data model. And I can probably measure how many records do I have in my database. So database is accessed like a dictionary, and basically if you have a model employee, DB for employees is basically database of records for employees. You can measure length of it, and of course you can query it like that, for example. So here are all the Johns from the database, and you can get a little bit more complicated than that. So we have some operators which you can use in queries. For example, right like this, where I select all Johns whose salaries are more than 100,000, I guess. And here we go, the query worked, and we have all of them. Or I can do, let's say, a text search. I guess I didn't import that. I'll just probably import star. So just to import all the operators. Okay. So you can do full text search, where I search for United Kingdom in description, and apparently there is only one person who matches that. And actually these objects are the objects stored in this object database. So so this is an object of type of your model which you defined, and you have all the fields which you had over there. And now a little bit more like something a little bit more financial. So, oh yeah, maybe I actually can show how the encrypted data looks like, just so that you can see that the data are actually encrypted, even though it's not hard to make it looking gibberish, but that's what it actually is. So you have a bunch of encrypted blocks, each encrypted with AES-256, so you can see AES-256 as a signature, but other than that, it's just encrypted gibberish. And for something more financial, you probably would like to work with something like data frames and stuff like that. And for that, I've added very simple data like that, even though it's quite a bit bulky. I've added to a database of records like this. So I've indexed timestamp, the price from the last trade, and I didn't index volume. So and I just defined some methods to print these objects a little bit prettier. So okay. So now I want to basically query that. I actually have everything is defined in my demo, so I will probably import just like that and connect to the database. So I'm connected to this database of trades, and I have how many trades do I actually have? I have something like 6 million rows over there, and I can do something like pretty much something like this. So I'm querying I'm getting the trades somewhere from the range of 1st February of 2015 to 2nd February of 2015. And did I forget to close the bracket? Yeah, I did. Okay. And the good thing is that I'm not downloading that all at once. I'm iteratively getting these trades as I slice the result. So I could do actually something like this, which selects all trades from February 2015 to the last date in the data set, which is actually in December. So it's actually about 70% of the data set. But instead of downloading that all at once, I'm running this query and getting to the head of it. And as I'm slicing this data set, I'm actually hitting the database. So, and I actually promised some data frames, so let's do that. So I want to, let's say, plot a piece of the data set, right? So I want to plot it from this date, 1st of May, 2015, to like basically this time plus 1 hour, right? So I just want this little piece of the data set. So, and let me get that. So I'm getting data in that range, from timestamp in that range. And that's how it looks. And I guess now I want to get a pandas data frame out of it. So I can just convert this data set to a list of dictionaries, and then that data frame will work. Okay, here we go. So, and after that I can just plot data from this data frame. So which is just, yeah, actually I can plot last trade and volume, and yeah, something like that. And I guess I had a little bit more in the demo. Actually, I can select, let's say, the trades with price higher than something, and it would look like that. Well, and of course I can disconnect from the database just to finish this. There we go. All right. So that's it. Any questions?
Are you planning on doing Django support at some point? Are you planning on supporting Django at some point?
Django. Yeah, it's definitely possible.
There seems to be a lot of overlap with what you've already done.
Yeah. So actually, the syntax is a little bit expired by Django ORM. And probably what would make even more sense is Pyramid framework, because Pyramid uses ZeroDB, and this is ZeroDB is based on ZeroDB. So.
Can you comment on performance?
Yeah, so with performance we have you have two bottlenecks. One bottleneck is basically usual encryption overhead, right, which you would have if you do encryption at rest. And this is more like this is actually happening on the client side, relevant to what this particular client is querying, right? And then you have a latency overhead. So if you outsource your database somewhere to AWS, you have an overhead due to these round trips when client is talking to the server, because it's actually doing more requests than one to do one query. To make it better, we actually do a little bit of caching. So for example, if you have a 50 gigabyte index and do a simple query on that, you would have maybe 3 to 5 round trips per query. And with caching, with 5 megabytes of cache, for example, it would be like something like 1.5 round trips in average. So And that's basically latency latencycy between your client, which has the access to the keys, and database server, multiplied by probably 1.5. Depends on complexity of your query. Any other questions?
You guys, enough time for questions.
Many large companies, they want to give their data to third parties, say, but they want to provide anonymity to the data or the people that are in that data. They don't want to give that information where the third party can know them to know specifically about the person that they're analyzing. Can you use ZeroDB to provide that anonymity, or is this just helping?
What do you mean by unlimited?
For example, you came up with different customer data,
Mm-hmm.
what they're earning. Can you use ZeroDB so that third party, if they were using this, accessing the data in the server, they won't be able to find the exact name of the person. They can look at the demographic and do the data science aspects,
Right. Yeah, I guess how we work, we actually provide third parties access to what they are allowed to access, right? To some subset of your data set, right? But if you want to do, if you want to actually obfuscate data for analysts, you can do that using function preserving encryption, of course. Let's say if you substitute some, first names and last names with some deterministically encrypted tokens, that would work, but this would be vulnerable because you could easily figure out statistics about that, and these statistics, if it matches with the official statistics of first and last names, you would pretty much deduce what is in the database. So you need to do it very carefully, depending on what exactly you are doing, right? So, for example, if you have salaries, right, you can have order preserving encryption of salaries, but then it's a very limited amount of analysis you can do on that, and at the same time you have the data kind of vulnerable. So if you want to obfuscate data, it's really requires some serious thinking how to do that properly without vulnerabilities and still having functionality. And what we allow you to do is just to temporarily give permission somebody to work on your database or a part of it, and revoke this permission after some time in a cryptographically secure manner, so that, let's say, if that person leaks their private key and somebody takes it and hacks the server, they cannot get anything because the transformation key is already removed. Yeah, so for the scalability, I would say we do support replication and scaling the storage up, and scaling the so since we actually support MVCC, we can scale the reads, but not maybe not writes, because all the writes at the moment mostly do go through. We actually use object level locks, and since we have everything end-to-end encrypted, you are pretty limited in terms of what kind of conflict resolution you can do server side. We actually plan to do something for that too, because even when encrypted, you can do something, but I would say some databases which are designed specifically for scalability, they would probably beat that.
Just to clarify, is this multi-threaded?
Yes.
Okay.
I have one question. Maybe I missed something because I was busy tweeting about it. But in the end, it didn't look like that it would be really Pythonic in a certain sense. Do you have any plans to have a higher level wrapper, like writing a data frame directly and retrieving it directly. You know, it's kind of
Interfacing the whole database as a data frame. Maybe what you
yeah, it's one example. You know, it's kind of.
Right.
I'm thinking of this TS table thing, which solves a very specific problem, but it does it quite nicely.
Yep.
You know, I retrieve something, and it is a data frame. So,
Right.
and when I retrieve something here, I would expect it to be a data frame as well, and not like doing this Dictify thing. And
Yeah, I expected somebody to bring this up because if you use it to use it like specifically for data science, you having that as a data frame, would be good. It's easy to implement, but we didn't have any people so far interested in that because we didn't really talk much to the data science community. But I guess if it's interesting to have everything end-to-end encrypted and still do data science in it, we can actually do that because it's not hard to.
I would include that in my demo portfolio. I like the idea because me selling Python and cloud infrastructure and everything is kind of, you know, they're always saying, oh, we cannot put that stuff in the cloud, whatever it is. Even if it's public data, they're speaking about that. You know, it's more like having a good feeling. But if you would have some kind of, it doesn't have to be kind of the general thing, but kind of very specific case where I say, I have this data frame, nothing else, and I can write it and I can retrieve it. As simple as that. Like an HDF store, an encrypted HDF store or whatsoever.
Yeah.
I can imagine that it's not that hard to write such a wrapper.
That's right. It's
standardized back-end thing where you say, well, this is narrowed down to the structure of the data.
I think back when Pandas was, or maybe it wasn't Pandas, maybe it was by tables, they've been choosing what kind of backend to use for themselves, and they chose HDF5 over ZeroDB, which they considered because it didn't really quite work for them, but apparently, if you optimize it correctly, it will work. They just didn't do that, and I've seen some effort to build scalable data frames in terms of ZeroDB, and that works. But the problem is that it's not like encrypted over there, and we can just do that end-to-end encrypted, yes. If enough people want to do that, want to use it.
Let me know whenever you have something.
Yeah, definitely.
Any more questions? Good, then thank you. Great.
Thanks.
Jorge is up next.